In this lesson, we are going to learn about thermal stress and thermal strain. Suppose these are two walls, okay, and here a rod is fixed. Length of the rod is say L. Coefficient of thermal expansion, linear expansion of this rod is alpha. And suppose the temperature increases by delta T, right? So what is the change in length of the rod because of this increase in temperature? Rod actually cannot expand. If the rod was free to expand, delta L would have been L alpha delta T. This if the rod was free to expand, but the rod now cannot expand. So in effect the rod will get compressed by so much. So there will be compressional strain because of this. Right? The rod would have expanded but is not able to expand. So now it is getting compressed, and that compressional strain will be delta L by L. That is the definition of strain. So this we divide by L, right? L alpha delta T divided by L gives us alpha delta T. This is the compressional strain. How to get compressional stress? Right? Y is stress by strain. So stress is Y into strain. Therefore, compressional stress. Compressional stress. This will be Y into compressional strain. So we'll get Y alpha delta T. This is compressional stress. Right? You understand this, right? Y equal to stress by strain. Therefore, stress is Y into strain. Right? And stress is force upon area. Right? Stress is force upon area. So, force will be stress into area. Therefore, because of this stress, there will be a force on supports. And that force on supports will be Y alpha delta T. This is the stress. You multiply by area, right? Stress into area give us force. So that will be equal to Y A alpha delta T. So this is how we find force on supports. So here we have learnt about thermal stress and thermal strain. A wire is fixed between two walls, not a wire, a rod is say fixed between two walls. So this is a rod. L is the length of the rod, alpha is coefficient of linear expansion, delta T is the change in temperature. If the rod was free to expand, it would have increased in length by L alpha delta T, that you have learnt in thermal expansion chapter, right? Delta L equal to L alpha delta T. Now, because the rod is not able to expand, it experiences a compressional strain, and that compressional strain is delta L by L. That will be L alpha delta T by L. L will get killed, so we get alpha delta T. This is compressional strain. When you multiply compressional strain by Young's modulus, you get compressional stress, and that becomes Y alpha delta T. And when you multiply this compressional stress by area, you get force on supports, that will be Y A alpha delta T.